Okay, this is Algebra 1, a supplementary lesson on lesson 90, more on division of polynomials, and I apologize, yesterday's video was so long. This is kind of a process that has given some students problems, so I wanted to kind of make sure and explain it a little more in depth. And as far as videos and length of videos, we're over the hump. It won't get any worse than that. We'll get a lot better. So I didn't mean to scare you there with 26 minutes. It took actually longer to upload the thing and babysit it while it was uploading to YouTube than it did to make it. So I don't want to make another video that long either, because it takes the amount of time to take the video and to upload it. It was like an hour and a half out of my life to make that video. So not saying that you're worth it, but I'd rather spend some time doing other things. So anyway, same type of problems in today's lesson. The only specialty, the only twist to it, okay, we notice we have a division of polynomials here, and it's going to be the same thing. We're going to express it in long division format, and we said the first step when we do that is we have to list them in descending orders. Okay, now we notice of powers, so here we're dividing that binomial, this polynomial in the numerator, by this binomial. The x minus 2 is what we're dividing by. Okay, but we notice it starts with a term x to the third. That's our highest power, but there is no x to the second power. There is no x term. It goes directly to a number. And we have to realize when we do that, and we do this long division method, we must account for all of those descending powers, even though they're not there. Okay, well, how do we do that? Well, we simply express the fact that we can express that as there is a term in there, an x squared term, but it's multiplied by 0. Okay, so that way it is there, we're accounting for it, but it doesn't have a value. It's 0. It doesn't exist in our expression there. Okay, and the same thing with the x term. We're going to put that x term in, but we're going to put a coefficient of 0 in front of it. That way we've accounted for it, but we haven't affected the value of the expression. Okay, then we can put the value of our number in, our last number. Okay, now don't let that throw you. Yesterday I compared this process to long division using this long division problem here. Okay, 49,107 divided by 12, and we notice we have a 0 in the tens unit right here. Okay, so as far as that goes, for this number 49,107, there is no tens value. Okay, but we still account for that in the placement in the order of the numbers, because if we left that 0 out, we would have 4,917. Okay, that would be a totally different number, but we must account for that value where the space lies in the tens unit. We do so with a 0, even though the tens value has no value. Okay, and it's the same thing here. We must account for each descending order of the variable, even though it doesn't have a value. Okay, so it's the same thing that we're doing there. So the drill is the same when we divide. So we have it in the proper format, both by the expression we're dividing into and the one we're dividing by. They both have to be expressed in that descending order. Okay, we look at the first term. What must I multiply x by to get x to the third? I must multiply it by x squared. Okay, well, let's go ahead and do that then. X squared, x minus 2. Now, the book doesn't have this particular step that I'm doing off to the side. And if you can do it right here in your head and transfer it down here, that's fine. I like to do it and then draw my distributive symbols because it helps me keep out of trouble. Okay, so x squared times x is x to the third. X squared times a minus 2 is a minus 2x squared. Okay, and I draw my line to subtract. But remember, I'm not subtracting. I'm going to change the sign of those terms and then add them. Okay. By the way, when you multiply that out, if your first term doesn't come out to be exactly what this term is above it, okay, then you've picked the wrong value up here. That's why I like to do that to double check. So the first term checks out. They're both, this is x to the third, x to the third. That's what I needed. So I've made the proper selection of that. Okay. I go ahead and add those terms. Okay. These come 0. These add to 2x squared. Okay, because I have a 0 there. Okay. Then I drop down my next term. Okay, even though it's a 0, I must account for it. And that's why you see how we have to account for it. So then I look at my first terms again. What must I multiply x by to get 2x squared? Well, I need a positive 2 for one thing, and I need another x. Okay, so let's go ahead and multiply those out. 2x times x minus 2. I get a 2x times x gives me a 2x squared. I made the proper selection. Okay, they're the exact same term. A 2x minus 2 would be a minus 4x. I draw my line to subtract, but instead I change the signs and add them. These cancel out. This I get a 4x. Okay, I drop down my next term, minus 5. I look at the first terms. What must I multiply x by to get 4x? I must multiply it by a positive 4. Okay, let's multiply it out. 4 times x is 4x. 4 times a minus 2 is a minus 8. I draw my line to subtract, but I don't subtract. I change the sign of the terms and I add them. Okay, these two cancel out. I get a minus 5 and a plus 8. It comes up to a positive 3. Okay, I have no other term to drop down. I'm at the end of my polynomial, so this is my remainder. And remember, how do I express the remainder? Okay, what is it? Is it positive or negative remainder? It's a positive, so I get a positive sign. I put the remainder part, it's going to be a fraction. We're going to express the remainder in the form of a fraction. Okay, we're not going to put that r, remainder 3. We're going to express it as a fraction where the remainder is the numerator of the fraction, and what we're dividing by, x minus 2, is the denominator of the fraction. Okay, and so this is our answer for that problem, practice problem A in your homework set. Okay, going through the exact same process that we did in yesterday's lesson. This one, where all we did is we put in zeros for descending power terms that were not present in our original problem. And that would apply too if we had missing terms in that what we're dividing by, because we could have a 3-term polynomial that we're dividing by. If we're missing a term, we have to account for it here. We're not going to be getting into that in these types of problems, but you will have missing terms inside the division symbol. You must account for them. Here we have an x to the third, an x to the second, an x to the first, and then there is no x term. It's just a number for the last term. Okay, so we have to account for all of them, even though they're not there. In the same way we have zeros in our division problem. We can't ignore that 0 placement in the tens unit there. Okay, so I hope that helps for today's lesson. Let me see, check in your syllabus. I think you just have review problems tomorrow. Yes, there will be no video lesson tomorrow. Our last 2 weeks of the course, I'm going to focus on graphing methods. We've got into the slope-intercept method, and we're going to do some other things with graphing for the remaining 2 weeks. I think that will take us up through we'll be picking and choosing lessons through the end of the textbook. So we have 4 or 5 lessons on graphing for the remaining 2 weeks. So that's gonna do it, and we're gonna be practicing these problems that we've introduced lately in the review sets probably next week, and then drop them off for that second week, and we'll just focus on graphing problems then. So hope that helps for today's homework. Have a great weekend. No lesson or homework for Friday. So long for now.